Okay, today we're going to do some more adding and subtracting of polynomials. And really remember, all you have to remember is that it's basically just combining or adding the like terms. So in this first example, we have two polynomial expressions that are being added together. Notice that the parentheses here are not multiplication. They're really nothing more than grouping symbols because I have this plus sign, this addition sign, in between each set. Okay? A common mistake is to overlook that, and people want to start multiplying things together. But notice that these are just grouping symbols. So to add these two polynomials, we're simply adding or subtracting the like terms, or combining the like terms. And I always want to have it in standard form when I'm done. So I always start by looking for the largest exponents. So I look here, I've got an x cubed term at the front, and here's an x cubed term over here. So if I take 4 and negative 5 and I add those together, then I have a negative 1x cubed. And then I'm basically done with those terms. And the next thing I do is I look for the next largest power. So I look for any squared terms. Okay? I've got a 4x squared and I have a minus 2x squared. Remember, we always take the sign that's in front of the term. So 4 and minus 2 gives me positive 2x squared. And I'm done with my x squared terms. Next thing I do is I look for x to the first, or x terms. Okay? So I've got negative 3x and I've got negative 4x. So negative 3 plus negative 4 gives me negative 7x. And I'm done with the x terms. And the only thing that would be left would be the constants. So I've got a positive 10, I've got a minus 4. So 10 and minus 4 leaves me with a positive 6. And there is my new polynomial in standard form. Okay? If I were naming it by the degree, a degree 3 means that this is a cubic polynomial. Okay? So let's look at another way that we could set up that same problem. Sometimes it's helpful if we set these problems up vertically. Just like when we were adding numbers. If I was adding 100 plus 203, then one of the ways we did that, we learned that we could line up the columns based on the unit. We lined up the ones column and the tens column and the hundreds column, and then we added those things together. We're basically able to do the same thing with polynomials. We line up the constants, we line up the linear, the first degree, the second degree, the third degree, so we line them up by their like terms, by their degree basically. And we add vertically. 10 and negative 4 gives me a positive 6. Negative 3 plus negative 4 gives me a negative 7x. 4x squared and negative 2x squared leaves me a positive 2x squared. And positive 4 and negative 5x cubed gives me a negative 1x cubed. So you'll see we have the same solution with the vertical arrangement as we did in the previous example with the horizontal arrangement, where we were simply combining like terms. Okay? You can use whichever method you're most comfortable with. It really makes no difference at all which one you use. Right? So let's look at this example number 2. And again, you could do it horizontally. If you prefer to set it up vertically, you can do that, whatever you're most comfortable with. I tend to just leave them in a horizontal fashion and then go ahead and combine the like terms. So here notice that we've got a subtraction problem. So I'm taking whatever in the front polynomial and subtracting whatever's in the back polynomial. So I'm going to start with, I have an x cubed minus 7x cubed. So 1 minus 7 would give me a negative 6x cubed. Then I move to the x squareds. I've got a negative 3x squared minus 5x squared. So negative 3 minus 5 gives me negative 8x squared. Then I go to my linear terms. I've got a 5x in the front polynomial, but notice in the second polynomial there is no x term. So I simply carry that negative 5x down to my new polynomial. And the last thing would be any constants. Well, the first polynomial has no constant term, but the second polynomial has a constant of negative 12, so I simply tack it on to the end. So I have a negative 6x cubed minus 8x squared minus 5x minus 12. And again, I have another cubic polynomial. Okay? So take a minute and in your notes, go ahead and try these two got it problems. And again, it doesn't matter if you set them horizontally or you set them up vertically, either way. Pause the video, take a minute to try those two, then pull the video back up and see if you did them correctly. Alright, in part A here we've got a subtraction. So I look for the largest degree. The largest degree is the cube. So I've got a minus 4x cubed at the front. There is no x cubed term in this second polynomial. So I'm going to carry the minus 4m cubed. And then I'm going to go look for my next largest degree, which would be a 2. Well, I don't have any m squareds at the front. So I could think of that as having a 0m squared at the front minus the 4m squared. So 0 minus 4 would give me negative 4m squared. When I look at the m terms, I've got a negative m minus m. So if I take negative m minus m, that gives me negative 2m. And then my constants, I've got positive 9 minus negative 12. Positive 9 minus negative 12. Remember that double negative there becomes a plus, so I have a positive 21 as my constant. Okay? It's easy to make mistakes with the subtractions. There's little things with the subtraction that we can miss, and this double negative thing that occurs is one of those mistakes that's commonly made, so pay close attention to those. In part B, we've got addition. So I scan, I see that the largest degree is the squared. So I've got a 7x squared and a minus 2x squared, and I'm just adding here. So 7 plus negative 2 gives me a 5x squared. I have no x term, so I can think of there being a 0x plus negative 4x means I've got a minus 4x. And then my constant is positive 9 plus positive 9, which gives me positive 18. So there are your two polynomials, your difference and your sum. Okay. So let's take a look at this. Take a minute and read this word problem and figure out what it is we're trying to set up. So we've got two polynomials here. We've got one function here for carrots and celery, and we've got a second function for broccoli. The question says, what polynomial models the total, total number of pounds in millions of carrots and celery and broccoli? So if we're trying to get the total of all of those things, this means we're going to take the sum. We're going to take those two polynomials and we're going to add them together. So the negative 12x cubed plus 106x squared minus 241x plus 4477, and we're going to add, I'm going to do this one vertically just because I don't have a whole lot of room. We're going to add the 14x squared, so I have a positive 14x squared, a minus 14x, and a positive 1545. And we're going to add those two polynomials together. So I'm going to do my addition. So over here I have 4477 and 1545. So that gives me 12. I can carry 11 and 12 carry. That's 10 and carry, and that gives me 6. So I've got a positive 6022. Here I'm adding two negatives, so I can just add the numbers and keep it negative. So there's an x, and this gives me 5, 5, and 2. So that's a minus 255x. We got 106 and 14, so that gives me 120x squared. And there is no x cubed, so I can think of it as a 0x cubed being added, so I have a negative 12x cubed at the front. So there is our polynomial that represents the total sum of both of those polynomials together. The negative 12x cubed plus 120x squared minus 255x plus 6022. Okay. All right, I want you to try a couple more of these on your own. Again, if you do it horizontally or vertically, it doesn't matter. Pause the video, do these two problems, and then check them against my answers. All right, in part A, we've got subtraction. So I'm looking for the largest power. I'm looking for these cubes. So I have a negative 4x cubed minus 3x cubed gives me a negative 7x cubed. Okay, done with the cubes. Then I'm looking at squareds. I've got 6x squared minus a 4x squared. 6 minus 4 gives me positive 2x squared, and I'm done with the squareds. Positive 9x minus positive 7x, so 9 minus 7 is positive 2x. Negative 3 minus 12 gives me negative 15, and the difference of those two polynomials is now here at negative 7x cubed plus 2x squared plus 2x minus 15. In part B, I've got a sum, so again I start with the largest degree, so I got 2x cubed and a 3x cubed, and when I add those I'm going to have 5x cubed, and I'm done with the cubes. I've got 2x squared plus a negative 4x squared. 2 plus negative 4 is negative 2x squareds, and the x squareds are gone. Negative 3x plus, notice there is no x in the second polynomial. It's like a 0x term in there. So I still have a negative 3x. And my constants are 5 and negative 7, so 5 plus negative 7 gives me a minus 2. Okay? So hopefully you're getting the hang of these adding and subtracting of these polynomials. Okay? So tomorrow we'll see if there's any questions that we need to clear up, and then we'll work on some more practice problems in class. We'll see you then.